Hey guys, so in this video we are going to discuss and solve separable ordinary differential equations. Some ordinary differential equations can be reduced to the form g of y dy plus f of x dx equal to 0 by purely algebraic manipulations. Okay? So that is, the variables can be separated. So, kung mapapansin nyo, yung x natin only appears on one term, and then yung y naman natin appears on the other term. So, after transforming a given differential equation into this form, we can easily obtain a solution by integrating both sides of the equation. So, if f and g are continuous functions, then the integral exists, and by evaluating them, we obtain a general solution. So let's take this example here. So we are going to find a solution to the ODE 1 plus x dy minus y dx equal to 0. So we can easily separate the variables by dividing both sides of our equation by 1 times 1 plus x. So in our first term, we will be left with dy over y kasi magka-cancel out yung 1 plus x. And then for our second term, we will have dx over 1 plus x kasi magka-cancel out yung y. And then on the right side, that is 0 divided by y times 1 plus x. So that is still equal to 0. So now we can see that the variables are separated. Sa first term natin, puro y lang yung variable natin. And in our second term naman, puro x lang. So to obtain the solution, we can simply integrate both sides of our equation. So the integral of our first term will be equal to ln of y. And then for our second term, that will be ln of 1 plus x. And of course, the integral of 0, that will be equal to a constant. So let's just put c. So by the quotient rule of logarithms, this difference will be equal to the ln of y over 1 plus x. After this, we will just take the exponential of both sides of our equation to cancel the natural logarithm on the left side of our equation. So by the law of exponents, this term here will just be reduced to y over 1 plus x. And on the right side, e raised to a constant number, that is still a constant number. So let's just write c1, where c1 is equal to e raised to c. So this is now our final solution. Again, recall that the solution of a differential equation is a function free of any derivatives. So wala na tayong derivative na nakikita dito. Ibig sabihin, this is now our solution. So we can also rewrite our solution as y equal to c1 times 1 plus x. As you can see, napakadali lang isolve ng isang differential equation if we can separate our variables. So the solution obtained in this problem contains the arbitrary constant c. This solution is called a general solution. Okay? Pag merong arbitrary constant, general solution yung tawag natin dun. So the opposite of this is what we call the particular solution. So on the other hand, a solution that is free of any arbitrary constants. So kapag walang arbitrary constants, we call that a particular solution. So a particular solution can be obtained from a general solution with the help of given conditions. So in our next example, we will see what these conditions are. So here in our next example, we are going to obtain the general and particular solution of the given initial value problem. So we have a differential equation here, dx over dt equal to 4 times x squared plus 1. And then we are given a condition. So sabi doon, x of pi over 4 is equal to 1. Again, we will use this condition in order to obtain our particular solution. So as you can see, we can easily separate our variables here. So we can have dx over x squared plus 1, and then yung dt, ilipat lang natin sa kabila. So that will be equal to 4 dt. Okay, so let me just rewrite this. So both of these terms will be on one side of our equation. And let's just equate this to 0. So once we have separated our variables, we can proceed with integration to obtain our solution. So the integral of this first term will be equal to arctan of x minus the integral of our second term, so that is equal to 40, and that is equal to the integral of 0, which is just a constant c. So now we have this solution, and if mapapansin nyo, meron tayong arbitrary constant c. Therefore, yung tawag natin sa solution na to is a general solution. Now, to obtain our particular solution, again, that can be derived from our general solution and from the given condition. So again, our given condition here is x of pi over 4 is equal to 1. Ibig sabihin, yung value ng x natin is equal to 1 when our t is equal to pi over 4. Okay, so we will just substitute this to our general solution. So we will have arctan of x. Again, for x, we will substitute 1, then minus 4 times t, which is equal to pi over 4, and this will be equal to our constant c. So now we can obtain the value of our arbitrary constant given the conditions. So make sure na naka-read yan yung calculator nyo. So our arbitrary constant will be equal to negative 3 pi over 4. So therefore, our particular solution will now be arctan of x minus 40 equal to negative 3 pi over 4. Okay? Again, particular solution free of any arbitrary constants. So wala na tayong constant dapat na makikita dito. Okay, so we can also rewrite this particular solution as x equal to the tangent of 40 minus 3 pi over 4. Okay, that's it. See you on the next video.